Good day, and welcome back to our discussion video on limits and continuity of functions of several variables. We are viewing part 1, which concerns limits of such functions, and it has been concluded in the previous video. Let's now go to part 2. Here we want to show that these 4 limits do not exist. Okay? So again, let's recall, we need at least 2 curves passing through the target point. In this case, they are all the origin. No? We need at least 2 curves such that if we evaluate the limit of these expressions along those curves, they will produce different limits or the limit does not exist. So yun yung kailangan natin. Okay? All right, let's do that with number 4. Let's show that the limit of 2xy over x squared plus y squared does not exist. Okay? Again, we need 2 curves going through 0, 0. Yun yung gagawin natin, no? For the next 4 items. Take 2 paths through 0, 0, producing different limits. Okay? Here, we will take C1 as the y-axis, x equals 0. While for C2, it's going to be y equals x. Try natin yan, no? Now, let's take limits along each curve for C1. So ito siya. Note that C1 is x equals 0. We just replaced it, yung sa baba. And the trick here is to replace x in your expression by 0 because it is the constant, and then let the other variable approach its corresponding target, which in this case is 0. No? So here, we will take the limit as y goes to 0 now of the expression where all x's here are replaced by 0. Okay? And now let's check. The numerator is just 0 kasi may times 0. While the denominator is not yet 0. It just approaches 0. So essentially, we have 0 over non-zero. So we have 0 for the limit along C1. Okay? Now, if we take the limit along C2, which is y equals x, same yung gagawin natin. Pero dito, yung y ang papalitan natin. We will replace all y, all instances of y, by x, so that we reduce the limit into a limit of just one variable, in particular x going to 0. Okay? Doing the replacement of y by x gives us this. So we have 2x squared for the numerator, 2x squared for the denominator. Their quotient is 1, which is not 0. Okay? And that's what we want. 2 different limits along 2 distinct curves going through 0, 0, so that we obtain our desired conclusion, that the limit does not exist. Okay? So that's item number 4. Yun lang. Ito, dalawa lang sapat na, no? Let's try now item number 5. We want to show that this limit does not exist. X minus 3y all over square root of x squared plus y squared. Okay? Let's take maybe this one. It goes through 0, 0, no? So let's take y equals 0 and see what happens. If we plug in y equals 0 in this expression here, we get a limit going to 0 for x of x minus 3 times 0, which is just x, over square root of x squared plus 0 squared. Now be careful here. This denominator, the square root of x squared, is going to be the absolute value of x. Hindi lang siya basta x, no? Yung x, it will work for positive values lang. Pero kung negative yung x, then we take the negative of x. Okay? So we have the limit of x over absolute of x, which has two limits. If your x goes to 0 from the right, it's going to be 1. While if it is going to 0 from the left, negative 1 yung limit. Okay? And this is the case where we have a limit that does not exist. Sa iisang curve pa lang. Okay? And this computation here is enough for us to conclude what we want, that the limit does not exist. Okay? That's item number 5. We did not need another curve. Okay? Now let's try item number 6. Let's show that this limit does not exist. X plus 2y cubed quantity squared over x squared plus 4y to the 6. Well, let's take some curves going through 0, 0. Well, two obvious question mark candidates are x equals 0 and y equals 0. For the succeeding curves, we will go through the limiting process a bit faster. Let's go. Sa C1, x equals 0. So papalitan natin ng 0 yung mga x dito, leaving us with a limit as y approaches 0. The numerator here is 4y to the 6. The denominator is also 4y to the 6. So the limit is 1. Okay? Meanwhile, the limit along C2, which is y equals 0, can be reduced into a limit as x approaches 0 of the expression where all y's are replaced by 0. So it's going to be x squared over x squared. Yung kukuhanan ng limit, it's also equal to 1. Oops. Hindi natin type to, no? I mean, dapat kung dalawa lang, solve na, no? But that does not allow us to make any conclusions yet. Hindi porket parehong 1 yan, may limit na. There might be some other curve out there which gives a different limit, no? So let's look for one such curve. Baka meron pa. Kunyari, ito. X equals y cubed. Tingnan natin ha kung uubra ito. By the way, this is motivated by the presence of the y cube. Kasi diba may y cubed quantity square. So you could think of that. No? If you cover the x's here, may 2y cubed dyan na naka-square. So parang pwedeng gawin yung x palitan ng y cube. No? If we do that, the limit along C3 will be this one. Let's replace the x's by the y cubed so that we have a limit y going to 0 of this one. And let's simplify. to get this, which when the y to the 6's go away is pretty different from 1, no? Pretty much different from 1. It's, yeah, 27/5. So from there, yan yung gusto natin. To conclude what we want. So the limit indeed does not exist. Okay? That is item number 6. And finally, for item number 7, interesting. We have an ln. But yeah, we can deal with this, no? Let's go. Show that the limit does not exist. Well, let's take two curves going through 0, 0. Sige, ito kung napapansin nyo, para siyang quote-unquote default, no? We start with x equals the target x coordinate, y equals target y coordinate, and then work it out from there. Na kung magpareho, tsaka lang kukuha ng iba. Okay? Let's see if we need to do a third curve for this one by checking limits along C1 and C2. Yung sa C1, x equals 0, ganito. So we replace the x's by 0, and we get this. The numerator becomes y to the 4. The denominator is y to the 4 as well. So it's going to be 1. While at C2, this limit along y equals 0 becomes a limit as x approaches 0 of the y to the 4, they will disappear essentially, no? They will be 0. And we are left with ln of 1 minus x squared over x squared. Yikes. It's 0/0. Indeterminate. Well, kung hindi man kayo fan nun, okay lang. Hopefully ay fans kayo ng L'Hopital's. Ayan. So L'Hopital's makes its first appearance in Math 23. Ayan. Hopefully naalala, taking the derivatives of numerator and denominator, respectively, gives us this limit. The numerator has derivative 1 over 1 minus x squared times negative 2x, like this. And we will divide it by the derivative of x squared, or 2x. And doing some cancellation and plugging in x equals 0 gives us negative 1, which is not equal to 1. Therefore, the limit does not exist. Okay? And that's it for item 7 and for part 2 of our discussion. Okay? So that's how we show limits do not exist for functions of two variables. Finally, for part 3 of this discussion, we will be checking for continuity of some functions of two variables. Okay? So pakitry po muna itong items na to before proceeding to part 3 of our discussion. Alright? See you there sa part 3.